Today, we'll look at Anova. Anova stands for Analysis of Variance. Now, this is an analysis tool used in statistics that splits an observed aggregate variability found inside a dataset of two parts: systematic factors and random factors. The systematic factors in this case have the statistical influence on the dataset given, or the random factors here do not. Analysis of variance test is mainly used to influence that the independent variables have an effect on the dependent variables. This could be in a regression study. Now we're going to look at a one-way and a two-way ANOVA. A one-way and a two-way ANOVA. Now before looking at them in their particular code, I would need you to understand the format of the one-way and the two-way ANOVA. This is one of the simplest topics in quantitative methods and takes only about 30 minutes to understand. So the one-way ANOVA has the following sources of variations. We have a treatment, we have the error, and we have the total. So we use SS to stand for sum of squares. So SSTRT, sum of square treatment, sum of square error, and sum of square total. The degree of freedom, which is used mainly in reading the tables, we have the degree of freedom for the treatment, error, and total. K minus 1, N minus K, and N minus 1. Then this column has the mean of squares. So MST stands for mean square treatment. MSE stands for mean square error. Then we have the F calculated, which is simply given by the mean square treatment over the mean square error. So ANOVA is a component of hypothesis testing where we're testing variations that emanate from more than two datasets. So 3 and above, we use analysis of variance. A two-way ANOVA is slightly different because amongst the sources of variations, we have one component, which is a block. So this is what makes it distinctive. So we have treatment, block, error, and total. So the sum of square treatment, SSTRT, sometimes just leave it as SST. We have the sum of square block, sum of square error, and sum of square total. So this is K minus 1, N minus 1, and you apply the 2, K minus 1 times N minus 1. Then this is N minus 1 for degree of freedom under total. So the mean square treatment, these are just abbreviations or acronyms. This is MSTRT, or MST, which is sum of square treatment, mean square treatment, mean square block, and mean square error. Then when we divide the error into each of these ones here, we have what we call the F calculated. Now, sum of square block is what makes a two-way ANOVA distinctive. In layman's language, you can say it has two titles. Here, if we have A, B, C, and D. and here we have X, W, and Z. So this is a two-way Anova because the variation is coming from the blocks, which in this case are the rows. So these are denoted by small n, and the columns, which in this case are 4, denoted by the letter K. The elements that are in a two-way Anova are even. What I mean is you have a regular randomized block like this one here. So we have the total number of elements that are 12. So our capital N is 12. So this is how a two-way Anova looks like. A one-way Anova has one source. Key source of variation can come from 3, 2, 4, 4, 1, 2, 2, 2, 3. So this is a one-way Anova. So we only have what? K here, the number of treatments, which are the numbers of the columns we have. This is 3. We don't have small n. Okay, even if they were regular here, as long as there's no title this side or a source of variation, it is still a one-way Anova. So what is our capital N in this case? The total number of samples. We have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this is 9 as our N. So now we're going to learn how to balance what we call the Anova tables. So on a one-way Anova, we've been given the data as follows. So SS treatment, what is our sum of square treatment? 40. So on SS treatment, we're going to put what? 40. And the total, we're given what? 85. We're going to put 85. Then the sum of square error is the difference. So what is the difference between those two?
45.
It's 45. Okay. So we're going to put the difference because the totals must always add up to what? The total down there. So here, treatment, we had what? 40. Total, we had what? 85. Then the difference here for the error will be 45. Okay. Then we have the degree of freedom for the treatment. What was the formula for the degree of freedom for treatment? It will be k minus 1. What is our k?
-1.
What is our k? What is our k?
Okay, it's 5.
5.
5 minus 1, which is what? 4.
4.
Then what is the degree of freedom for the error? N minus k. So 20 minus what?
5.
Which gives us what?
15.
And the total here, what do we get when you total this up?
19.
19. Good. Then to get the mean square treatment, we divide the answer here into that answer there. So the sum of square divided by the degree of freedom. So what are we getting here?
10.
10. All right. Then down there, what are we getting?
3.
3, yes. Mama Cow, are you there? How we got the 3? Mama Cow, are you getting where we got the 3?
No, I'm a little bit behind.
Okay, Yolanda, explain how we got these figures here. The mean square is simply when you divide the sum of square over what? The degree of freedom. So this answer divided by that answer, we get 10. If 5 divided by 15, we get 3. Is that clear? Amaka, is that clear?
I couldn't hear you. You were silent, so I didn't get anything.
So how do we get the mean square? We are dividing the degree of freedom into the sum of square. So this 4 into the 40 is 10.
Into the 40, okay.
This 15 into 45 is a 3. Are we together?
Okay, yes, I get it now.
So to get the f calculated, we divide now the mean square error into the mean square treatment. So the 3 into 10, we get what? 3.33. Is that clear?
Yes.
Okay. Then from here, you now need to read on the tables. So you now need to read on the tables. Our F tables are 3. We have one, which is a 5% table. So the percentage is in the title. We have a 1% and a 0.1%. So you need to be certain which one of these percentages has been given. So when we go back to our question, the question is, we have been given what? We have been given our Level of significance. What is our level of significance in this case? 5%, isn't it?
5%.
So to read this table, we go on 5%, 4,15. 5%, 4,15. So let's go to the table there. The reading is in such a way that from this angle, we get the degree of freedom for the error. From this angle, we get the degree of freedom for the treatment. So the degree of freedom for the error was what? 3. It was 15. The degree of freedom for the treatment was what? 4.
4.
So we're reading under 4,15. So from the error, we check 15. From the treatment, we check 4. Okay. I said from the error, we check under what? 15.
15.
Then here, under what?
4.
Where they meet. Under 5%. So you tell me, we go to 5%. This is yes. So here you check under what? 15.
15.
Then there we check under what? 4. So where do they meet?
3.06.
3.06. So here we put 3.06. Then our decision will always be when this figure is more than that, we reject.
We reject.
Okay, let's have a recap quickly. We're just learning how to balance up. We're given the K, which is the number of columns, then N, the total sample size N, and SSTRT, sum of square total, and SSTO, sum of square total. This is sum of square treatment. So our sum of square treatment was 40, we put 40 there. Sum of square total was 80, we put 80 there. Then how did we calculate the sum of square error? It was a difference. Sum of square error was found by sum of square total minus sum of square treatment. So we found what? 85 minus 40. 85 minus 40. This is what gave us 45. Is that clear?
Yeah.
Then the degree of freedom for the what? Treatment. Degree of freedom for the treatment. How did you find degree of freedom for the treatment? It was K minus 1.
K minus 1.
Which was 5 minus 1, which gave us 4. And we went to the degree of freedom for the what? Error. How do you find the degree of freedom for the error? N minus what?
N minus K.
Which was what? 20 minus 15,
5.
which gave us 5. And finally, the degree of freedom for the what? Total, which is always the same as N minus 1. So what is our N? 20 minus 1, which gives us 19. Or better still, we just add these two. Then to find the mean of squares, we simply divide the sum of squares over the degree of freedom. So the 40 divided by 4 is 10. 45 divided by 15 is 3. When to find the F calculated, we divide. What is this 10? It's called mean square treatment. So F calculated was a mean square treatment over mean square error. So how did you find 10 divided by 3, which was 3.33? Is that clear?
Yes.
Then finally, we went to the table. How do we find the FT at 5%? We use the coordinates of the error in the coordinates of the what? Of the treatment itself.
What treatment?
So 4,15, which gave us the reading as follows. So we went here, 4 and 15 where they meet. This comes from the error. This comes from the what? The treatment of the blocks. So it made at 3.06. So that is how we found our 3.06. Let's do the same for the second one, the two-way Anova. So secondly, to make the decision, we always reject if this is more than that. Okay, reject HO if the F calculated is greater than the F tabulated from the table. So that's why we're rejecting, because this one is more than that. So suppose we're given our small n was 4, and our sum of square block was 45. Then here our sum of square total was 130, and level of significance 1%. So let's go through the way we're doing it. What do we put under sum of square treatment? What is our sum of square treatment?
40.
40. Sum of square block?
45.
45.
And sum of square total?
130.
So how do we find the sum of square error?
130 minus 85.
The difference, huh? So sum of square error will be sum of square total minus sum of square treatment minus sum of square block. So it will be 130 minus what? 40 minus 45. What are you getting? What are you getting?
45.
45. Is that right? So the 45 is a difference. Then who remembers what is the degree of freedom for the treatment? What is the degree of freedom for the treatment? K minus 1. K is 5. So 5 minus 1 is 4. What is our degree of freedom for the block? What is the degree of freedom for the block? According to the formula, it is the number of blocks minus 1. So small n minus 1. What is our small n? What are we given? How many small blocks do we have? What is our small n? So 4 minus 1 is
4.
what?
To get 3.
So here, that's a 3 here. Then the degree of freedom for the error. What were we told? Who remembers? It's k minus 1 times what? N minus
N minus
minus 1. So the answer here times the answer there. So 4 times 3, which gives us 12. So we're going to put 12 here. Okay. Then what do we get? The sum of square total. Degree of freedom for total.
Is it 19?
Yes, we total them up. We get 19 or n minus 1. Then how do we get the mean square? How do we get this column? We simply divide these answers in there. So the degree of freedom for the treatment into the sum of square for the treatment. So here, what are we getting?
10.
And here, what are we getting?
15.
15. Here, what are we getting?
3.75.
3.75. Okay. So a two-way Anova has 2f calculated. So we'll be dividing this into there, this into there. So the f calculated here.
Is that error into treatment?
Error into treatment and error into block. So when you divide MST divided by MSE, we get the f calculated for the what? The treatment. So we're dividing 10 divided by what?
3.75.
What are you getting?
2.6.
2.6.
2.67.
0.67. So we put it here. 2.67. How about here? How do we get the f calculated for the block? MS block over what? The mean square error. So we get the f calculated for the block. So we're dividing what? 15 divided by what?
3.75.
To get
4.
Oh,
so we put 4 there. Then we need to read the f tabulated for the treatment and for the block separately. So the f tabulated will be 1%. And what are the coordinates for the treatment? usually against the error. So the degree of freedom for the treatment over error. So this is 4 comma what? 4 comma 12, right? 4 comma 12. How about the degree of freedom for the block? It will be 3 comma what? This 3 against the 12. For the treatment, this 4 against the 12. So you're all referring them both subject to the error degree of freedom. So let's go to the table. What percentage is that? 1. The first coordinate is 4 comma 12, then 3 comma 12. So look for 1%. This is 5. 1%. So 12 is the error. So our error will be here. Then 4 comma 12. 5 point what? 41. And 3 comma 12. 5.95. So what do we put here? What did we get here? 5.41. Then here 5.95. So what is the decision here? Are we rejecting? Are we rejecting or we fail to reject?
I think we fail to reject.
Because the decision rule is always to reject when f calculated is more than what?
Is greater than the.
So here we fail to reject, and here we fail to reject. So this is how you balance up a two-way ANOVA. So when we go to our question of reference, we could as well try a similar question, an exam type of question. So I'll give you some homework to do, but let's look at this here. An exponent has concluded for 4 treatments and 8 blocks to complete the following variance table. So Anova, how do we find the missing figure here? So what is our K and what is our small n and what is our big N? What is our K? Already given. How many treatments are there? 4. So our K is what? 4. And how many blocks do we have? 8. When we multiply this times that, we get our N. What is our N? 32. So to get the sum of square error, we add this and we subtract from the total. So 900 plus 400, subtract from 1800, you put your figure here. And the degree of freedom for the treatment is K minus 1. So 4 minus 1 will be 3. Degree of freedom for the blocks is N minus 1. So 8 minus 1 is 7. So you multiply the 3 times the 7 to get 21. Then when you total up here, you get your sum square. Your degree of freedom for the total. The mean square, we always divide the degree of freedom into the sum. Then this one is a 2-way ANOVA, so we are going to have 2f calculated. This you check under 5% to test whether to reject or to fail to reject. I require this week. Those of you in the evening class, this will be your homework. So I've told you what to do. The other one is the same. You're given sum square, total, treatment, and block. You're asked to set up an Anova table at 5%. You've been told accountants were 4, and we've been told that there are 5 auditing procedures. Accountants will be treated as treatment, meaning the other ones will be treated as what? Blocks. So this will be your homework. Just conclude. Unless there are any questions, please ask. Our next session will be on regression analysis. Please find time to join the physical classes from 9 to 15 if you're available, or find time to join us over the weekend from 9 to 17 for revisions. So for these and many more videos, remember to inbox me or to attend any of our classes. Thank you and have a good day.